Alright, we're going to quickly run through the members that we didn't get to in class. So we're going to look at this roof beam A to start, and then we'll look at the roof girder. So for this beam on the roof, we're going to start just like we started the other problems by identifying the tributary area. Just like every other tributary area we do, we're going to go halfway to the next member of the same type. So here's the adjacent beam to the one we care about, highlighted in blue. We're going to go halfway there. We're going to go halfway to the other beam, to the adjacent beam on the other side. We're going to go halfway there. And if we stand anywhere in this shaded region, our load is going to go directly to the member we care about, roof beam A. So the loads that we need to consider are always the dead load, and we also on the roof are going to have to deal with the weather effects and potential occupancy in terms of live load. So let's look at what we're dealing with up above. All right, we have dead load issues, we have snow, rain, and live load. This is L sub R, right? This is not the L when we start talking about load combinations, right? L is for occupancy. L sub R is going to be its own category dealing with loads on the roof. We also have some dead load information regarding the beams. So let's start with the easier load. Let's start with the dead load. And for that, if we look back up above, we need to consider the weight of the slab as well as the superimposed dead load. Those are both given to us in PSF. So our distributed line load for those are 46 PSF plus 10 PSF times 8 feet. Right, the 8 feet being the tributary width of our tributary area. Right, we're selecting the dimension that is perpendicular to the member we care about for tributary width, because ultimately we are going to draw a beam member that is 25 feet long with a distributed load made up of QD and the other loads that we're going to calculate shortly. Right. The key is our 25-foot length from the tributary area is already accounted for in our drawing, so we need to account for the other dimension, which is the 8 feet. So if we do this math out, we get 448 pounds per foot. We need to include the self-weight of the beam. And if we look at what's given, it's a W 17 by 22, so that will be 22 pounds per foot of weight. Let's add them up, get our total dead load of Q sub D equal to 448 plus 22 is 470 pounds per foot, or 0.47 kips per foot. Alright, so that's our distributed load on this drawing. Let's look at the live load now. Step 3. Push up. Alright, for our live load, we can consider a reduction, but hopefully we know that we shouldn't be reducing on this roof. Right? There's no reduction due to restrictions from ASCE 7, Chapter 4. All right. If we look at the loads that are happening on the roof, we have L sub R is 20 PSF, snow is 40 PSF, and rain is 25 PSF. We're going to choose the largest one, because if I can carry 40 PSF, I can certainly carry 20 or 25 PSF. Alright, so we're just looking for the largest one of these values, because when we go to put it in load combinations, we only use one of the three. We don't use more than one at a time. Alright, so let's calculate. I'm going to call this Q sub S for snow. It's 40 psf, again, times the tributary width to get the units of pounds per feet. This gives me 320, or 0.32 kips per foot. What we're ultimately trying to get to for a beam member is the moment. Right, that's what we want to plug into our LRFD equation. So we're aiming for a design moment, right? And hopefully we remember our moment diagram looks like a parabola with a max value of WL squared over 8. Right? If you don't remember that, look at table 323 in the AISC manual for the moment diagrams. Alright, so let's look at our design moments. We're going to have a moment due to that dead load, Q sub D, L squared over 8, which is 0.47 times the length of 25 feet. Right, our beam's 25 feet long. Squared is equal to 36.7 kip feet. We also have a live moment, QL, L squared over 8, 0.32 times 25 feet squared over 8, because it's 25 kip feet for our moment. Alright, so we've got the moments. Our last step is to do the load combinations. Alright, if we look at all of our load combinations, you can write them all out. Alright, these are 0.9 D. We have no wind and seismic, so these are going to be smaller than equation 1 always. Here we have 1.2 dead plus 0.5 snow, so 1.6 snow, 5 snow, 0.2 snow, right? This is always less than equation 3, so we're going to check these two. Here I'm going to get 51.4 kip feet, and here I'm going to get 84 kip feet. So ultimately my M sub U, right, what I'm going to plug in to this LRFD equation, my factored loads are less than or equal to my factored strength. My M sub U here is 84 kip feet. Alright, it's the largest value for my load combinations.